Hi, Mr. Wright here, and welcome to this set of IGCSE exam questions, which are about grades 6 to 8. So these sets of questions are perfect if you're approaching your exams and you want to practice questions on a range of topics, all at a certain level. So hit the link in the description, download the questions, have a go, and then watch my worked solutions. If you find this film useful, please hit like, and if you have any questions, of course, leave them in the comments and I'll respond. Good luck.
Y equals x cubed minus 4x plus 4x plus 3. Find the gradient function. Okay, well, differentiate that expression gives me dy by dx equals 3x squared minus 8x plus 4. Okay, the diagram shows a sketch of the curve with the same equation. Good. P is a turning point on the curve. Work out the coordinates of P. Incidentally, I see there are two turning points. There's one when x is whatever that is, and there's another when x is whatever that is. So I'm probably going to get two solutions. I'm going to set the gradient function equal to 0 to find what x values give me a gradient of 0. So I'm solving this equation here. I'm going to factorize the left-hand side. It's got to be 3x and x. It's got to be minus and minus. Now, to make 4, try 2 and 2, shall we? Well, if I put 2 here, I get minus 2x, and then 2 there gives me minus 6x, gives me the minus 8x, so that's looking good. So I've got two solutions for x, 2/3 or 2. Well, clearly then, this one is 2, and that is when x is 2/3. I'm asked the coordinates of P. I know at P, I know that the x coordinate is 2, so I can use the equation of the curve to work out the y coordinate when x is 2. It's going to be 8 minus 4 times 4 is 16, plus an 8 plus 3, which gives me a y coordinate of 3. So the coordinates of P are 2, 3. Okay, write down the range of values for x for which the curve has a negative gradient. Well, it has a negative gradient between this turning point here and this turning point here. So it has a negative gradient when x ranges from 2/3 to 2. Now at 2/3 the gradient is 0, but anything above 2/3 the gradient will be negative. And then at 2 the gradient is 0 again, but only just below 2. So that's my range of values of x for which the curve has a negative gradient. And there's my solution to question 1. Question 2. P is directly proportional to q cubed. So I can write down that equation there. P is 270 when q equals 7.5. So substituting in p and q gives me that. So that would imply that k is 270 divided by 7.5 cubed, which is 7.5 cubed, which gives me a k of 16/25. So my formula is that p is 16/25 times q cubed. Find a formula for p in terms of q. I've done that. Work out the positive value of q when p equals q. Right, well here's my formula for p. P is 16/25 q cubed, and p has to equal q, so q will equal 16/25 of q cubed. If I divide all the way through by q, I get 1 equals 16/25 q squared. Multiply or divide both sides by 16/25 gives me q squared equals 25 over 16. So q would equal root 25 over 16. I'm asked for the positive value, so that will just be 5/4. Okay, so that is that. has 9 counters. Each counter has a number on it. Here they are, all the numbers from 1 to 9. Like, she puts the 9 counters into a bag, takes at random one from the bag, does not replace it, takes at random a second counter. Work out the probability that the number on each counter is an even number. Well, let's have a look. Of her 9 counters, she's got 1, 2, 3, 4, 5 are odd, and 4 are even. Right, the probability that both of her numbers are even. Well, the probability of the first one being even is 4 out of 9. And having chosen that one and not replaced it, the probability of the second one being even would be 3 out of 8. So the probability of them both being even is a sixth. Okay. Work out the probability that the number on the first counter added to the number on the second counter gives an odd. Well, what could happen here? She could get an odd on the first and an odd on the second. If she did that, then her total would be even. So we're not interested in that outcome. She could get an odd on the first and an even on the second. If she did that, then her total would be odd. So we are interested in that. She could get an even and then an odd, which would give us a total of an odd number. So we're interested in that. She could get an even, which would give us an even total. So we're not interested in that. So we're interested in the middle two here. Right, let's look at this first one. Probability of an odd followed by an even. Well, to start with, there are 5 odds out of the 9. If she takes one of those and doesn't replace it, what's the probability of the next one being even? Well, 4 out of 8. So the probability of that outcome is 20 out of 72. Right, let's have a look at the second possibility here. The chance of the first one being even is 5 out of 9. She doesn't replace it, so there are 8 left. Okay, and 5 of those 8 would be odd. So 4 out of 9 times 5 out of 9 is another 20 out of 72. So altogether, the probability of one or other of those events happening is 40 out of 72. If I divide top and bottom by 8, then I get the answer 5/9. Right, there is Gemma sorted. Right, P, Q, and R are points on a circle with a centre of O. So here's the centre of the circle. Oh, look at that. The radius of the circle is 5. I can see that quite clearly. QS is the diameter of a circle. Yes, okay. Diameter of QS and PR intersect at the point T. This looks like intersecting chords theorem to me. OS is 5 as marked. That's also the radius. QT is 3, TR is 6. Okay, work out the length of PT. Right, so intersecting chords theorem tells you that PT times 6, TR, equals 3 times ST. Now, do I know ST? No, I don't, but I know that's 5. This bit's 3, so OT must be 2. So now I know ST is 7. So 6 times PT equals 21. So PT equals 21 over 6, 3.5 centimetres. There we go, question 4. Question 5. Here are 7 cards. 1, 2, 3, 4, 5, 6, 7. Yes, there are. Harry takes at random 2 cards. Calculate the probability that the numbers on the 2 cards are the same. Right, well, that could mean then he can't get a 1 and a 1, but he could get a 2 followed by a 2, or a 3 followed by a 3. A 4 followed by a 4 is not a possibility. Right, the probability of getting a 2 followed by a 2 is 2 out of 7 multiplied by 1 out of 6. 2 over 42. And the probability of getting a 3, the first one, followed by a 3 on the second occasion, is 6 out of 42. So altogether, I get 8 out of 42, which is 4/21. Okay. Calculate the probability that the sum of the numbers on the 2 cards is 5. Right, we just need to think how that could happen. And would it work? Could he get a 1 first? He could. He could get a 1 followed by a 4, couldn't he? So he could also then get a 4 followed by a 1. He could get a 2. That would have to be followed by a 3, or a 3, which would have to be followed by a 2. So I think those are the 4 outcomes which qualify. So the probability of getting a 1 on the first card is 1 out of 7, because there's only one 1. Probability of getting a 4 is 1 out of 7. So that probability, 1 out of 6, of course, because there are only 6 cards left. So that probability is 1 out of 42. Right, probability of getting a 4 with this first is 1 out of 7, and then a 1 is 1 out of 6. So again, 1 out of 42. The probability of getting a 2 is 2 out of 7, followed by a 3. 1, 2, 3 threes out of those 6. So that's going to give 6 42. So the probability of getting a 3 is going to be 3 out of 7, followed by the probability of getting a 2, which is 2 out of 7, which is another 6 over 42. So altogether I've got 12, 13, 14 out of 42, which is 1/3, is it not? So the probability of the sum of the numbers on the two cards is 5, is 1/3.